Hi, I am Ashika Anand Babu, a student of Special Topics Class CMP 297, and my topic of interest is GNN in text classification. I have taken a paper called Review of GNN in Text Classification. These are the subtopics that I am considering. Introduction. In the graph-based text classification techniques, we are considering text GCN, text level GNN for text classification, magnet, short text, and a conclusion. So usually, deep learning techniques such as CNN and RNN have been used for text classification. The bag of words model is one of the simplest way to describe natural language. A more sophisticated model takes into account the relationship between the words in the text in addition to their frequencies. Graphs can depict that complex relationships. In the text GCN architecture, the word co-occurrence within the corpus and word occurrence in documents are used to construct edges between the nodes. The weight of the edge between the document and the word node is determined by TF-IDF. According to test results, a two-layer GCN performs better than one layer. This is the architecture. A two-layer GCN performs better than one layer, and adding more layers than two does not improve the model's accuracy. It outperforms all baseline models such as TF-IDF, CNN, and LSTM. Going to the next one, this innovative GNN approach builds graph for each input text while utilizing shared global parameters. Text level GNN for text classification model. All words in text are treated as nodes in the word graph and share an edge with words that are located next to them in text. The generated graph uses less GPU memory because it contains fewer edges and nodes than GNN models. And there are no text nodes in the model since they are calculated as sum of representatives of the word nodes, which saves memory, which is one of the benefits of this model in terms of memory usage. And these models perform better than the text GCN models because the main reason is because of the memory. It requires less GPU memory. Coming to the next model, magnet. Magnet is a graph attention network. GAT, which may simultaneously learn the adjacency matrix and the attention weights to reflect the correlationship between labels by modeling the correlationship among labels as a weighted graph. None of the previous models considered the correlationship between labels. So, what is the architecture? Architecture is the embedding matrix that serves as the first layer's input, and the output from previous layers is fed into the following layers. This improved the average MIF1 score by 4% compared to the GCN models. Considering the last architecture in this paper, which is the short text means tweets, chat messages, search queries, product descriptions, reviews on the products. The main problem with this kind of model is that it is considering short text, and the short text will always lack the necessary features and is extremely sparse in order to provide sufficient word occurrences. Unlike other text resources, these models, these short text corpora do not follow any grammatical rules. So the architecture for a short text model is a soft layer is placed after two layers of GCN. Short text model is used for product title classification and product query classification. In conclusion, graph neural and graph convolution networks for text classification tasks have outperformed the traditional and deep learning models on the same dataset. Thank you.